Hey everybody, welcome to Logarithm to Exponential and back again. So this whole video is going to be about switching forms, starting with a log form and going to exponential form, or starting with an exponential form and going to a log form. So in order to solve a problem, sometimes all we need to do is change perspective, and that's kind of the point of this video. What we're going to cover today, what are learning goals, so why do we need to do this, what's the point of switching these forms, how to go from exponential to log, and how to go from log to exponential. So why do we need to do this? Why is this an important skill to know? Well, it helps us solve problems like this. Okay, 10 to the x equals 27. X equals what? Well, 10 to the first is 10, and 10 to the second is 100. So x must be somewhere between 1 and 2, but how exactly do I figure it out? I mean, I guess I could guess and check. And after 100 times, maybe I'll get close, but switching forms would tell me exactly what the answer is. If I can turn this into a log problem, that would solve it for me right away. Similarly, 5 to the x equals 34. Well, again, what does x equal? Well, I know 5 squared is 25, and I know 5 to the third is 125. So I know x must be between 2 and 3, but what exactly is it? And again, log, if I could change this to a log problem, that would solve it out for me right away. Similarly here, log base 2 to some power equals x. Okay, well, how do I figure out again? This whole question is, okay, well, what is x equal? What is x equal? Because here, x is an input. This is an input. This is an input here. This is an input here. So what if there was a way that I could switch my inputs and my outputs? Oh, maybe by using the inverse. That's exactly why we're going to do this. So it helps us figure out what x is in all of these problems. So let's see exactly what that's going to look like. So let's start off. If you have an exponential, how do we switch it to log? So we also call this flattening the curve. So in this little diagram I have here to the left, exponential forms start off as y equals b to the x. B is going to always be the base. How does it switch? The base of the exponential becomes the base of the log. The base becomes the base, and because this is inverses, x switches with y. Right? How do we find an inverse? Switch the inputs and the outputs. That's all that happens. So the base stays the base. X, which was the input, now comes the output. Y, which was the output, now becomes the input. That's it. Okay? Switch the form. The base is still the base. Switch your x and y's, and you're done. So let's see that. So here's some examples. Switch it to log form. So it's in exponential form right now. I guess step one is recognizing what kind of form you have. So this is an exponential form because x is in the exponent. So 10 is the base. So 10 is the base. 27 is the output. So this is the output. So I need to change this to log. Okay, log base what? Well, 10 is the base of the exponential, so 10 is also going to be the base of the log. The base still becomes the base. X is my input here. 27 is my output. So this is an inverse. So inputs go to outputs, and outputs go to inputs. In other words, switch it. So 27 was the output, so now it's going to be the input. X was the input, now it's the output. Now I just stick log base 10 to 27 into my calculator and out pops x and I'm done. Alright, let's try this with 2 to the x equals 13. Okay, here's input. Here's output. 2 is my base. Okay, so I know I need to change this to a log. The base stays the base. Input becomes the output. So output then becomes the input equals x. So I go to my calculator, say what is log base 2 at 13? Solves it for me, I get x, solves that problem. Alright, 5x 34, so this is the base. That's the input. 34 is the output. Alright, base stays the base, inputs become outputs, outputs become inputs, so 34 is now our input, x is now our output. Plug that into a calculator. What is log base 5 of 34? We output whatever answer we get, and that solves the problem here. Alright, what if we have e? Okay, well, what's the inverse of e? The inverse of e is ln. Okay, ln is log base e, so e is still the base here. Here's the input. Here's the output. So switch input and output. So then my input will be what my output was, and my output will be what my input was. Inputs, outputs, switch. So there we go. Then calculator, what is ln of 23? That'll give you exactly what x is for that. So that's going from exponential to log. Let's now see log to exponential. We're going to do the same process. We'll just start with log. We'll create an exponential. The base will still be the base. We'll flop our input and output, and we'll be done. So we start off with log of 3 of x equals 5. Let's change this to an exponential. So an exponential, the base, so this is the base here. This is the input. This is the output. So those are the three keys we need. We need to know, okay, what's the base, what was the input, and what was the output? Okay, the base is still the base. Okay, so the base is still the base. The output is now the input, and the input is now the output. So for an exponential, it's base to power input equals output. Saying put a lot. So base input output, base input output. Alright, log base 2 of x equals 3. Base input output. So base, switch output and input. So that was the output, now it's the input. That was the input, now it's the output. Okay, so base stays the base, switch input and output. Alright, ln base e of x equals 5. So the base of ln is e. So there's the base. The input is x. And the output is 5. Sorry, the output was 5, so that is now the input. And the output is x. Serves me right. The one time I didn't label input and output and I screwed it up. Okay, so output becomes the input, input becomes the output, base is e. Okay, let me try to do this one without labeling. Okay, base is 5. The output is 30, so it becomes the input of the exponential. The input was x, so that becomes the output here. Okay, so now we've successfully changed forms as well as solved all of these problems just by switching forms. Amazing. So what we've learned, we learned why we need to switch the forms. It helps us solve these problems, mostly where we're missing a piece of information. How to go from exponential to log, and how to go from log to exponential. Either way, the base stays the base, and then switch inputs and outputs. So base stays the base, switch your inputs and outputs, right? How to do any inverse ever. So thank you guys for watching this video. I hope that helped. I hope those were good explanations. Ask questions, please, as always, as needed, and I'll see you guys in the next video.